Hi everyone, and welcome to the first lecture of this 2 weeks of hackathon. Before we begin, I just want to make sure that everyone on the Zoom can hear clearly. Feel free to everyone that joined online and physically. So I'm Chunjugo, a medical student from Monash University, and also I'm a member of the Chaos Lab, and I have been working on several projects inside the lab. So today the goal of this lecture is not really to make you to become like a full stack engineer that can build software from scratch or like memorize all the syntax or the language and stuff like that. But what I'm going to talk about more is how to code in the era of vibe coding. Because in vibe coding, which I will explain shortly, it's like your role has changed a bit. So you don't really need to like bricklayer anymore. You will approach a bit more like an architect. So it's like how the architectural consideration of the software. So vibe coding is a software development approach where a large language model generates functional code just by using natural language as a prompt. So some of you might have already heard of like Windsurf, Cursor, or like Codex. That is from like that. They are all like coding agent tools that you can use, and just by using general like English to like prompt it, it can make a software out for you. So today we are going to give you the blueprint for that architecture on like how you can code more effectively and communicate more effectively with the AI agents when you're doing vibe coding, which will be in like the next weekend workshops, which is mostly on vibe coding. So you guys will have a bit more exercise on how to do vibe coding in that workshop. So we designed this session specifically for those that have no prior experience in like coding. So we are going to demystify some of the jargons that you might have already heard, like maybe back-end, front-end, API keys, and vector database, and also like deployment. So we'll translate them into language that is way more familiar for us, which is like medicine. So I will use analogy that is more applicable to like medical students or like doctors. So to make this concrete, I'm not just going to show you the theory. I'm going to deconstruct one of my a real-world project called Clarity, which is one of the first project that I worked in the lab. So using a bit of like vibe coding and also the architectural considerations to make it more, to be able to build that software out. And also I'm going to cover some of the tips and tricks that you will be able to use it when you start to do vibe coding next week. So we'll kind of like tear it apart and also look at anatomy of the software and piece by piece, so you can see exactly how a medical idea can turn into like a full application. Hopefully by the end of today, you will have kind of like a meta view of the architecture of the software and also how to communicate more effectively with AI agents, which will come in handy after the weekend vibe coding session where we will merge all these ideas together and you can build something amazing that you want to build for this competition. And let's get started. So this is the agenda today. So I will start with about like the code first. So like coding language, the stuff, the codes, these are all like the backend and front end. So this is like the actual logic of your code. And then after that, I will move on to like some of the, I would say, tools and helpers that you can get, which is like libraries and frameworks or API keys that you can connect to make your software even better. And lastly, I will touch on some things that's related more towards a deployment. So it's like how your code actually, how the computer actually know how to carry out the codes and carry out all the functions that you want and the instructions, and also how you can deploy it inside the local and also the cloud and also database. So let me introduce you to like Clarity. So it's an AI-powered software that has access to real-life, like actual hospital guidelines and can answer clinician questions based on those guidelines. So at the time when we decided to start this project, because we saw there are a lot of doctors that find it, or maybe interns that find it quite difficult to navigate through all those like guidelines, and they find it really difficult to use the current framework to like find the best guideline for them. And that's when we started to think, why not we make an AI that can answer questions using natural language, using sentence that we all understand based on the guidelines that the hospital have. So this is also to lower the risk of hallucination as well. And we understand that for every different hospital, they have different guidelines as well. So it will be good to be tailored for that particular hospital guidelines. So this is a quick demo on like how the Clarity works. So you can see where they put in a query, which is on like maybe HSV management for pregnancy, and then it will give out the answers here based on the, let me put it again. Yep. So it will give query out based on the guidelines, the actual guidelines from the hospital, and then it will show you where does it come from. So it will show you the PDF that contain that specific guidelines and where it answers come from. Okay, so now I will start by some terms that I think is really important, and you guys will heard a lot about all these terms when you start to do vibe coding and stuff like that, because it's like how people communicate with each other. So computer science, you can think it as like a medicine. So it's like a powerful way of solving problems. And computer, as we all know, it's really strong with all those computational powers. It can do a lot of like complicated maths really fast. And how can we use it? We need to speak the language they speak. So that's why we have coding. So coding essentially is just a way to communicate with the computer. And so every solution, similar to like medicine, we have a fundamental logic. It is like the central dogmas that we have input with algorithm and output. So in clinical setting, the input can be like a patient chart. And when you look at the patient chart, you start to think, okay, you look at all those clues, all those hints, and try to form like a differential diagnosis based on it. And that is what we use, everything we learn and all those trainings we have over the years. So that is the algorithm, that how we process the input data. And the output will be the diagnosis. So for computer, input can be like, for example, in Clarity, the input can be the user query. So what is the management of HSV in pregnancy? And then after that, the algorithm will be the core part of the soul of the whole software. This is where the codes come in. It gives instructions on how the computer should process this piece of information, this input, and give out the output that you want, which is like the management. So what underneath the hood, the software can maybe get the information from your database, which is your guidelines, or they can send it to API key outside, which is an AI, to form a better response, a smooth response out, and then finally it gives out the output. So this is like a flow that every software runs. You give an input, the algorithm will be what you want it to do, the instructions, and it will spit out the output for you. And then after talking about the coding and computer, I want to talk about another term that is used all the time, which is software. So when we talk about software and app, I believe what we're thinking is like all those buttons and the screen that I just show you, the interface. So it is like the user-facing part of the whole program. But actually, this is just like the tip of the iceberg, as you can see from this image. The front end, which is the user interface, or the video that you see just now, is just the tip of the whole software. And underneath the hood, you have like the logic, the AI, how the data is processed, and everything is underneath the hood that is back in your back end that is normally normally it wouldn't be seen by the user. So a good analogy for this will be like, you can think it of software as like a hospital. So you have reception, and you have like the user or patient-facing side of the hospital, and that will be your front end. So of course, you need to make it look good and easy to navigate, and also it needs to be responsive and be able to tag in information. So that is the front end. And the back end is like the lab inside your hospital, where they take in blood samples and they kind of analyze your blood samples, analyze any x-rays, any imaging, and normally patient wouldn't go into that part of the hospital. So all the back end stuff is just to make sure that the whole software can run smoothly. So even like the technicians of the hospital and everyone like that, they're all considered under like the back end of the hospital to make sure that everything runs smoothly. So now move on to like how you can communicate with the software. So just like I talked about like all those terms, now I'm going to talk about coding language, which is the most important part. So the challenge right now is that because we can think in like English inside our brain, it's like a really complicated idea. But the thing is that computer only understands zeros and ones. They only understand binaries, the transistors. It can be on and off. That's it. So just a fun fact that you need to know everything you see right now, all the pixels, all the image, all the emojis, alphabets, words, and everything. They are just a combinations of zeros and ones. So in order for us to speak zeros and ones, we need a lot of tools. So that's why we have all those different language, and this is where Pythons come in. And after the next few weeks during the hackathon, you will have a lot of chance to work with Python, which is the main language that we'll be using for byte coding. Okay, so just a brief introduction to like those different types of coding language. So some of you might have already heard of R language that done like maybe some research, because R language is really popular in data analytics, especially in research. And then also you have like other different language, like lower level language means that they are more towards like, they're closer to binaries and machine codes. So they're closer towards the hardware. It's called C. Some of you might have already heard of it. It's a really, really fundamental and hard language because it is nearer to the machine code. So it will be more cryptic and harder to learn and have a lot of syntax. And another language that we will use a lot, which is Python, is way higher level. So you can think it as a spectrum. So the right side is like human natural language, the left side is binary. So for C language, it's more towards the left side, and then for Python, it's more towards the right side. So when you think about like which one, the strengths and weaknesses of all this language, so for C, because it is nearer to the binaries and machine codes of computer, it is faster. And it is more flexible, you can manipulate way more stuff. For Python, it will take a bit more time to actually interpret it because yeah, it takes longer time to change it from natural language into the binary or any language that the computer understands. So that's why it is important to understand that there are different language and they all have their own strengths and weaknesses and their own usage. So it will be good that you understand like what kind of knowledge, which type of coding language that you will use most, and then if have the time, can look into it, be more familiar with it, and this will help you even with byte coding. Okay. So clarity, this is like some of the language that we use for clarity. So for this slide, what I wanted to convey is that for all the software they're using, you wouldn't just use like one language. You'll use a combination of language because just like what I said just now, every language have their own usage. So for example, for HTML, CSS, and JavaScript, so for HTML and CSS, some people will say that it's a markup language rather than a coding language because what they focus on is more towards like the design of your front end. So how does it look like? How to make it look better? The colors, the font, and stuff like that. And JavaScript is important to connect your front end to the back end. So these are all front end language. You only use it in your front end. For Python, you use it for your back end, all the core logics, how to process the input, and how to form the output. So this is the core of the whole backend. You use Python. Of course, you can use JavaScript, and then you can use C. So there are all other languages for backend as well. So you need to find the language that you are more familiar with, you're more comfortable with when you are making software. Or sometimes, if you are doing some more complicated projects, you might need to use C, but that is not that often because that one is really complicated unless you need to kind of manipulate all those memories and all those like more deeper stuff. So important point is just that for a software, you have a combination of different languages that you need to use. So it's not only just one language. Okay, so now we just talk about different language like Python, JavaScript. And just like English, your French, and then Spanish, they all have like nouns, verbs, and adjectives. And so for all the coding language, they have some sort of like universal blocks or building blocks. So you don't really need to know like the exact grammar and how to write it word by word, but it will be good for you to understand all those terms, like what is the variables, because this is like how you can communicate effectively with the AI agent that helps you to code as well. And also to maybe your friends or like any teammates that are working on the same project with you. These are some of the terms that you use to communicate with them. So first of all, I want to talk about variables. So variables, this is similar to the maths variables that we all know, that it stores information, just like maths. So it gives a name to a piece of data, and so that we can use it or find it later. And it is important to note that for variables, for the names, you can put any names you want. So you can put X, you can put Y. And for some of the good practice, you can put the name that you want. So for example, if this information stores the weight of the patient, then you name it as the weight. So just make it clearer for the name of the variable. So you can put any name you want. So a good analogy will be like, you can think it as a labeled specimen cup or a labeled box on a shelf. So the label will be the name of the variables where it store the information. And the next kind of like really fundamental building blocks will be data types. So this is how we categorize all the information. And it is important to note that, to understand that you have a lot of different data types, and this is also to help your computer to understand what it should do to like process these data types. So you don't really need to understand all the different like integer, float, string, list, dictionary, but you need to be aware of the fact that you have different data types, and different data types is being processed differently by the computer as they take up different memories. And also, for example, integer. When you use integer, the software, the interpreter of Python will understand that, okay, this is an integer. So if the user try to plus or minus or divide or multiply something, they can do that because this is an integer. But if it is a string, then it might give you a boolean, then which is true or false, then it will give you an error message because Python understand that this is a boolean, this is not a number, you can't really plus or minus it. So that's why it's important to know that, to understand that there are different types of data, and all those different types is being processed and stored differently. Okay, now move on to one of the most important concepts in coding, which is functions. So the function definition is like a process of creating a name and reusable block of code that perform a specific task. And I will explain a bit more about it. Yeah, so you can think of toaster as a function. So toaster, what we use toaster to toss our bread, right? So it's like the unique function of the toaster. So you give in parameter, you can think as parameter as the input. So you give an input into the function, and then you give an output that you want. So the function is just a block of code with a really specific and unique instructions to it, like what you want to get from it. Okay, so because when we talk about functions, it has like a specific like rules and stuff, right? So for example, a functions that calculate BMI, it takes in weight and height. They are all numbers. But if this function that calculate BMI, and then you put in weight, and then you put in height, and then you put in age, you have 3 inputs. And then the function will be like, wait, I can only take in 2. I only understand weight and height, but I don't know why there's age. So there's like a third input that comes in that the function cannot recognize. And when that happens, what happens is that it will just crash. It will just send an error message to you saying that, okay, they will just have a really cryptic error message for that. So, for example, math.sqrt. So this function, as you can see from the name, is to calculate the square root of the numbers. And then if right now you put in -3, you just say that it's a maths domain error because you can't square root negative number. So they all have a specific like rules in terms of what input you can put in. It's like you can only put in 2 inputs, or you can only put in integers. So it can be like the numbers of inputs you put in, or the data types that you can put in. So those are all like restrictions of functions. It is really strict in terms of like what you can put in. Okay, so abstractions. Abstractions, it's a really fancy terms in like computer science. It just shows that, it just means that it hides the complicated details so that you can focus on the goal. So for example, input and also like print, they're all functions that we use all the time when we are using Python. So for input, it's just that, okay, it will get an input from the user. It will ask the user what is your name, and then you put on your name, and then it will just take in your name. And that's it. That's the function of this input function. But actually underneath the hood of input functions, there are like few hundreds lines of code, because you need to teach the computer to know, okay, when the person type in the keyboard, how do I get the information from the keyboard? How do I display what is your name on the screen? So there are a lot of really nitty-gritty and really fundamental things going on underneath the hood, underneath this really simple input function. It's just that we don't really need to go into and code from like scratch on all these instructions. Because we already have people that have done all this job for us, we can directly use it. And this, I will talk about libraries and stuff afterward in the later slides, which is having a similar concept on like how people build a lot of stuff for us that we can directly use it and make our life way simpler. So remember, always when it comes to functions, focus on the high level logic, what you actually want to get these functions to do. You don't really need to worry about like all those really fundamental and nitty gritty side of the functions because other people already done that for you. And also, this modular code is more towards how you arrange functions, how to make it more organized your code. So every functions have their own unique tasks. So for example, in this flow chart, so it is for hypothyroidism where if you suspect hypothyroidism, you measure the TSH first, and then after that you measure the T4 level. So how can we organize this into like different functions so that it makes it more organized? So one way we can approach it is that, why not we have a function that just measures TSH. And then we have another function that measures T4 only. So when a user put in maybe a numbers, and then what you can do is that you process it, you go to the TSH first. You put the number inside the function that calculate the TSH level. And then after that, if the TSH is high, then you put the number inside. You put the T4 number inside the functions that calculate it, whether it's high or low or normal. So if you kind of like organize your functions in a way like that, where every single functions have a specific and unique task, when you try to decode, when you try to debug something, so for example, the output is wrong, it goes to like maybe primary hypothyroidism, where the person is like normal or something, and you try to debug it, what you can do is, you go and check the first function first, the TSH function, and check the output of the TSH function. Is it normal? Is it the correct answer? If it is the correct answer, then we move on to check whether the T4 function is the correct one or not. So it makes your life easier when it comes to when you try to debug it, because it separates all the different features and different aspects into like different chunks of code. So you can test them individually to see if every one of them actually works like what you want, because every one of them have a different functions. And this is, I would say, a simpler version. So just imagine that like for the clarity, we have pre-processing, we have embedding, we have a lot of steps, like more than 10 steps. And then you need a lot of different functions and features. And I believe in the future, like you guys will also work on projects like that. So if you just put everything in like one big functions, it will be really difficult for you to debug. You don't even know where's the code from. So that's why we want people to do it in a modular way. So yeah, this is just an analogy where you can see in the toaster, you have a lot of different kind of like component of it. And you can think of every component as one function where they carry out very specific tasks. Okay, so this is just a quick exercise to kind of think about like how function works and what it returns. So this is a function that returns true or false only. And this function will check if this tic-tac-toe game has already over, which means that someone managed to line 3 O's or cross consecutively. Anyone think that this will return false or true? Like, if you look at this. Yep, so this is false because none of them managed to connect 3 times, like in a row. So this is false, so it will return false to you, this function. So this is what I call like every function have a unique task. So this function is just specifically used to check whether this tic-tac-toe game has already over. And then what about this one? True, right? So you can see, okay, it managed to line up. So this function will check, okay, now I can see that cross have managed to line up 3 consecutive cross. So right now it will return true. So this is what function is basically. And yep. Okay, so now after talking about like how you, some basic understanding of like codes, variables and stuff like that. So you have kind of better understanding of what is a code and functions. Now I want to talk about style. So this is something that I found it really important every time when I'm starting a project, because this determines how easy it is for your code to be read and also other people collaborate with you. Okay, so this is something called digital hygiene. So just imagine like what I mentioned just now, like between different scripts. One script is with 500 lines of code. versus a well-organized project with every single like closet where all the clothes and everything is organized properly in the individual wardrobes. Which one is easier for you to read and also easier for you to navigate? That is essentially what I mean by the style of your code. So there are a few vital signs on like how a healthy or good code looks like. So the first one will be readable, and yeah, looks. So readable means that other humans, including you in the future when you decided to look back to your code, can you understand it? So when looking at the right side, so this will be the right one and this will be the left one. Which one do you think that even without any knowledge on like prior coding knowledge, which one do you think that you look at it and you understand what it is about? Is it the right one or the left one? If this function is to calculate BMI. This one, right? So as you can see, so just like what I mentioned just now, for functions, for variables, you can put any name you want. The thing is that you can put a dragon here, you can put Pokemon, you can put anything you want for the name. It's just that in the future, when you come back and look at it, you have no idea what this function is about. And your teammate will definitely hate you if you do it like that. So as you can see for this one, the calculate BMI, that directly name the function on what it is about. And then you use weight and height because you know that this is the weight, this is the height. So when you try to debug, just imagine if you try to debug it and you notice that you put the height at the numerator, then you know that, okay, something's wrong because you make it really clear that what's the formula that you are using. But if you just put C, X, Y, stuff like that, then you have no idea which one is the weight, which one is the height. And when you try to debug, you will get confused on like which one is weight, which one is height as well. So it will be harder for you to debug. And then the next one will be modular, which is something that I mentioned before. So you can see in these slides, we have a lot of like, you have different functions. So you want this full assessment to check whether the heart rate is too fast or too slow, and also to check the temperature, whether it's a fever or not. So as you can see right now, this program have two functions. One is to check the heart rate, another one is to check the temperature. So one way is you can put everything in one big function. This is definitely doable. There will be no error message or anything like that. It will still run and it will still work. Another one is where you organize it into different functions. So you have one function that check the heart rate, another function that check the temperature. So the good thing, so the one that is better style will be the one with different separate functions. So this is because when you look at this one, because right now you only have heart rate and temperature. What if in the future you have maybe oxygen saturations, you have maybe blood pressure, you have even more. And then this will make this whole kind of like bunch of code really huge. It can get like maybe 50, 60 lines of code in just one function where everything is in it. And imagine right now you have something wrong with the maybe blood pressure code. And then it'll be really difficult for you to actually find it because it's like everything is in one block. And it's really, you need to go through one by one and look at the code and see if there's anything wrong. But when you organize it in individual functions, you can just directly go to that function that has the problem and check if that function is working. You can test all the functions individually. So for example, if I want to check whether the heart rate is right or wrong, I can directly print out whether it's going to return normal or not. So I can directly see if it is returning the correct result or not and debug it. And the next one will be robust. So robust just means that how good your software is at handling error gracefully. So, okay, so right and left. Also for you guys will be right and left. Which one will be? Which one do you think is a better way of handling error? Right side. So as you can see, this program will also run if you give in a valid input. So which means that if you give like 500 and then 2 for the number of those, it will be able to return you a valid result. But there are a lot of different, what we call edge case, where what if the user put in 0? There's nothing that stop the user from doing it. And when it put in 0, because you can't divide something by 0, then it will return another maths domain error. But for this one, when you do the same thing, 500 and 0, it will return the error message that you already set it earlier. So the the good thing about this is that you have a better idea on what's the problem right now. Because if you do it like this, it will just show you there's an error, but you have no idea what the error is. But in this case, when you use, okay, so this try and accept, you can take it as if else. It's just for error handling. So when it will try this line of code first, if there's error that comes up, then it will see whether the error is this zero division error or type error, which type of error that it shows up. And it will give you the line of like what the error is, the reason of the error, based on what you put in. So when you saw this error cannot split P into 0 parts, then you know, okay, the problem right now is because I accidentally put the number of those into 0. So you know where the error is, because it is really straightforward. You make it really straightforward that you know that that's the problem. And in actual like Clarity projects or any projects that you're working, you will use a lot of this try and accept block in like maybe API keys and stuff like that, because they kind of like, because it can have a lot of different type of errors, and the error message can be generic and also can be really vague. So when you look at the error message, you have no idea what's happening if you don't do the try and accept. Okay, so now I'm going to touch a bit about like vibe coding trap. So this is what most of us that have done quite a lot of like vibe coding kind of like experience, and we think that it is good for you guys to be aware of it when you start vibe coding next week. So one of them is, it's important to note that because AI, they can form code really fast. They can form like 100 lines of code in like 1 minute or less than that. So, but sometimes it can get really messy if you don't look at it and organize it. So for example, if you let it stack up like maybe 1,000 lines of code, then when you realize there's some error in it, and you try to go back and look at it, you have no idea what is going on. And also, in larger files, AI will forget the context. So for example, you have a huge project with like 4 or 5 Python files. Every Python file has like few hundreds of codes. The AI won't be able to look through all the files at one time and manage to pinpoint the error for you, because there are just too many stuff. And all the AI have a context window. They have a restrictions in terms of like what they can tag in. And another thing about using AI is that when they're fixing error, what they will do is that they will keep on making new files, tests, and stuff like that. And they will not remove sometimes they will not remove the code that doesn't work. So in that case, after you've done everything and then it runs and look at your code, it will be like there are a lot of codes that you don't even know why it exists. And it might be true that it is not useful at all, the code. And it's something that you should already remove it. So for example, in like the Clarity project, the first part is like pre-processing PDF. And PDF have a very complicated layout. So you have flowcharts, you have tables, you have text and everything like that. And all of them need to be processed differently. And just imagine, okay, right now you have problem processing flowcharts, you have error. And then you need to try different attempts on like how to get the information from the flowchart accurately. So what it does is that you have a lot of test file. You test file 1, test file 2, test file 3 to find the best file. And what happened with vibe coding is that it will help you to form all those new files. And at the end, when you manage to run it, and you have at that time, you will be like, okay, so which file am I using right now? You have test file 1, test file 2, final file 1, final file 2, final file 3. You have a lot of names like that is formed by the LLM. And it can get really messy where you look at your directory with like 20 different files and you have no idea which one is the actual working one. So as a result, you will have like an unreadable black box of code. So this is how, okay, so this is an overview on how we organize the Clarity project. So this slide, what I'm trying to convey is that it is not only important that you organize individual codes in individual file, it is also really important for you to organize the directory, the file, just like what I mentioned just now, where you can have test file 1, 2, 3, 4, 5, 6. You have final file 1, 2, 3, 4, 5, 6. You need to always go back, look at it. If this is outdated, remove it. If this is the actual one, keep it, rename it better. And also another key part is that you can see how we separate front-end and back-end codes into different folders. So the front-end code are all under the SRC, and then all the back-ends are under the Fast App directory. So this is just how we kind of like make sure that specific rooms are for specific tasks. And even for the back-end, we have a lot of different functions that we need to create. We have file to create embeddings. We have files to connect to the database. We have files that load the document and everything like that. So we actually, even inside the backend, we organize them into different files. Okay, so now I will move on to debugging. So debugging is a really useful tool, even in the era of vibe coding where the LM, like Cursor or like you use ChatGPT, Claude, they can actually help a lot in terms of debugging. But sometimes there will still be times that you need to give more specific instructions on how to debug it. So debugging, you can think it as like a differential diagnosis. So these are the process that you can test, you can try when you're trying to debug something. So the first one will be, okay, so I'm going to give a scenario when trying to go through this step-by-step of debugging. So right now we have a simple function to calculate the BMI, so weight and height. And then the bug right now is that the user enters the height in centimeter rather than meter. So as a result, because you divide it, and if you use centimeter, it will be a really big number. When you divide it, your BMI will be really, really small, like 0.00 something. But in this case, you won't see any error message because the software is still running. And then it's just the only problem is just the number is really weird, but no error message at all. So in that case, how can you kind of analyze what's the problem? So, okay, so the first thing, what you can do is you can try to reproduce that error. You can try it with different numbers and see if this happens for every numbers or not. Just like how a patient presented with maybe abdominal pain, you will do palpation to check where's the exact point of the pain. So you try to reproduce it and and the next part, which is isolate it. So you try to isolate which part exactly is the pain. Is it right upper quadrant? Is it lower quadrant? Or is it like, where's the exact location of it? So in this case, we only have weight and height. So what we can do is we check the weight and the height, which one is wrong. We can actually ask them to print it out and see which one is wrong. And now, if you print it out, you realize that the height is 175. And you know that the height should be in meter. When you look at the 175, you know that there is something wrong there. So what can you do? You can start to form hypotheses on what can cause that 175 to be here. One way is that maybe the math formula is wrong, and another one is the user entered in centimeters rather than meters. And the first one is kind of unlikely. The math usually will be right. Then you know that, okay, so maybe I should test it out if that's the case. Then the next step will be test. So you test it out. You check if the height is too big, why not you divide it by 100 and see if the answer is valid or not. And where you see 22.8, then you know that that's the problem. So this slide is also related to vibe coding. So when you start to do vibe coding, there are some different like tips and tricks and also stuff that you need to be aware of when you're trying to debug. So even vibe coding, you can still have a lot of errors and bugs. They are not like perfect. Like humans, they will make mistakes, they will miss something. So when giving information to LLM, try to be specific, like how we do medical handoff, like how we have this ISBA like framework to do medical handoff. Try to make it as specific as possible. Under what circumstances this error happened, what's the input, and then what happened when something went wrong, and what are your thoughts on it. Then the more specific information you give in, the better it is for the AI to understand the problem and fix the problem. Another thing is that when we are doing vibe coding, I noticed that a lot of times where the AI might say that, okay, I fixed the problem, and then your software is working, congratulations. And when you run it yourself, you'll see a huge red error message. So if possible, always try and test out whether it is actually working or not. If not, you can just continue to debug it with the AI. Okay, so just now I talked a lot about like codings, backend, frontend, like how you make the code works. So now I'm going to talk about external like tools that can help you to build your software. One is libraries, frameworks, and package. So in medicine, when you treat a patient, you use different medication. And you don't really need to make the medication from like the chemicals, right? You already have it, you just need to prescribe it. So right now, that's the same thing with coding. So especially Python. Python is so strong is because of the fact that they have a lot of different libraries for different kind of functions. So every time when you're trying to maybe make a software with some sort of like features. So for example, making a facial recognition software, you can always search it up whether there's a library that can already work that way. So I know that there are libraries that make jokes for you. There are libraries that actually done the facial recognition for you. So you can directly use it easier, so you don't really need to code the whole thing from scratch. That will be really difficult. Yep, so this is like the hierarchy on like how the library package and module is arranged. So the library is where what you install. So when you use the LLM or like the cursor to run a program, they will usually ask you to download something using like pip install something. So what you're installing are libraries or codes that people already done. So when you download it, you can directly use the code that other people have already made it for you and use that functions. So that's the library, and then underneath that you have package and module. So I'll use an example for this. So NumPy is a really popular library in Python that is used to deal with maths, metrics, and all those like calculations and stuff like that. So under NumPy, you have different package, like array package, you have random package. So the one that you're using, the functions, is actually this one, the last one, the module, the ran-in. So inside the module ran-in, they have a lot of different functions underneath it. So for example, right now, you're trying to make a software that can speed up random number, which is actually quite difficult, but you don't really need to do that by yourself from scratch. You already have this ran-in library, package, or modules from the NumPy. So you can just directly install NumPy and import it, then you can use it. So that's the most powerful part of Python, where you already have a lot of people that make all these different libraries that you can use. So for example, you have this maths package that you can directly get pi number or exponential. You can get logs, or like they can do all the triangle like calculation for you. And then you have like date time, you have all these like different package that is already done, and you can just directly use it. And also you have some third-party libraries that is outside of Python, official documentation like NumPy that I mentioned just now, the matrix computation, and Panda. So Panda is also another one that we use a lot when we deal with numbers and stuff, because it is like Excel sheet. So it's good for data analytics, data science, and manipulation. Another one is Matplotlib that maybe some of you have seen it before, where it actually turns your code into graph. So you can actually make graph of like maybe your experiment or anything like that using Matplotlib. And PyTorch is something you use it for machine learning, like neural network and stuff like that. And Flask is for web apps. So it's like how you connect your front end and back end. So for Clarity, we use quite a lot of libraries. And these are just some that we use, some of the core libraries that we use for Clarity. One is Panda. So this is important because we need to analyze a lot of data and like numbers and stuff like that. Another one is LangChain. So LangChain is something that you might encounter quite a lot if you're trying to make like an AI-powered software like Clarity. Because LangChain, they give you a really good framework or like functions that can connect the outside LLM, maybe a Gemini or ChatGPT, to your software to give an output. So that's why we use LangChain to build so RAG, you can think it as a database of all the guidelines. And we want to connect that to the AI, right? Because we want AI to have access to the database so that they can answer questions based on that database. So in this case, we use LangChain because it makes the connection way easier. You don't really need to worry about a lot of those nitty-gritty stuff on the connections, because LangChain will help you to solve every one of those. And the last one is, of course, the AI, Gemini. So if you want to use like Gemini, OpenAI, or any other models out there for your application, you will need to import or pip install the library in order to use it, because they have functions to help you to connect to the server. Okay, so now we'll talk about API keys, which is somewhat similar to libraries in terms of that it is something external but can help your software to become something more interesting and can have way more features that you want and stronger. So API keys is also something you heard a lot when you start to build projects. So physically, it looks like a long password of random numbers combination. You can think of it as like the hospital ID badge or your credit card number. So it is something that kind of like represent your identity. So when you try to connect to like other server or other service like Gemini or ChatGPT, they use this to identify, okay, you are a valid user and we'll charge you based on this API key that you use. So that's why a golden rule is that never share your API key inside a public channel or share it to like websites or anything like that. You need to make sure that always keep it secret, because this is where people can directly use it and use up all your money inside your credit card. If you come like connect a credit card to that particular service, maybe your Gemini API key or your ChatGPT, this is where they can actually use it up. So just to clarify the concept of API keys and libraries. So libraries, you can think it as like a tool that you download and it runs in your laptop. So for example, Panda, I download it and it will just directly run in my laptop. So it depends on how good my laptop is, how fast my laptop is, how strong my CPU is when I try to run all these things. But for API keys, it is a bit different. So when you use API keys, it sends out to the server, external server, because you can't really run like maybe Gemini 3 models inside your own laptop. It will just melt down. It's not possible. You don't have enough computational power for that. So that's why we use API key. We connect it to like Gemini, the Google server for Gemini, or OpenAI server for ChatGPT, and then we send our input to them. They will form the answer and send it back to us. So that's how API keys works. So you can think as one is you buy the tools and then you do it yourself. It's like you use a scalpel and you be the surgeon by yourself. Another one is you find a surgeon to do the job for you. Okay, so why do we need API? Just like what I mentioned just now, AI models are just too big. You can't really run it locally on your laptop. Your laptop will definitely melt. It can't handle that huge like computational power and CPU. Like they require a lot of power. So that's why they have all those like big server station and buildings for like Microsoft and like OpenAI. And then, of course, for LM models, there are some smaller models out there in like maybe Hugging Face website where you can get open source model. You can download and run it in your computer, but you need to make sure that your computer meet the minimum requirement, or else you still can't use it. Okay, so now I will quickly go through like example of documentations and like API keys and stuff, because this will be really handy, and we'll also touch more in depth on this on the next workshops on like Wednesday. And during vibe coding, you will definitely need like API keys for maybe if you want to connect it to like some Gemini or like other LLM models. So the easiest way is actually to search it up, the docs for maybe ChatGPT or docs for Gemini. And then you will see this link where you can, when you click into this ChatGPT like website, it will have a quick start. And that quick start is usually the place where you go first to check whether like how to use this API key. Okay, so this is a screenshot taken from the website. As you can see, they give you a lot of options. You can use it for JavaScript. You can use it for Python. You can use it for all other language for backends. But okay, for us, we usually use Python, so I select Python. So there are some important things that you need to look at for when you look at the documentation, especially during vibe coding. One is the library. So this is pip install OpenAI, because all these different documentation, all these different APIs, they have a lot of different versions. They will update, try to make it better. And when they update, it is possible that they change the name. And sometimes when you use vibe coding, they might use the outdated version of that library. So they will try to pip install a library that is already no longer servicing. So that's why it's always good that you check the library first. Whether the pip install OpenAI, is that the one that you install when you're building your product? And another thing is the package and like what you actually import, the module. because this is also something that might change. The name might change after like maybe a few months. They will just keep on updating the whole documentation, the whole function and stuff like that. So that's why you always need to look at the libraries and the modules and also how you actually use it, like the functions. Okay, so now moving on to the next part, which is after we're done with all those functions, right now we have like a software with back end, with front end, connected to AI, and then it can do a lot of stuff already. It can take an input and give out output. But how can we make it actually working? So how can we make the code run? So one way of doing this is you use interpreter. So Python, they have interpreter that change, that kind of like convert the whole code that you have into something, into like machine codes or codes that the computer or your laptop understand. So that's why you have interpreter. And for C, they have like their own what we call compiler. So different language have their own like interpreter stuff that they convert this code into machine codes that the laptop or your computer understand. So there's few rules that is good to understand on like interpreter how that works. So first of all is that they run top to bottom, line by line. So they will actually go through, okay, the first line, check whether there is any wrong, whether they can run it or not. And then after that, it will move on to the next line and check if this is true or not. And then it will directly run it. In this case, the heart rate is 120. So it meets this condition of heart rate more than 100. So in this case, it will move on. It will print out alert tachycardia. So this is how your interpreter goes through line by line, top to bottom. And then after that, because this is else if, so else if only happen when this condition doesn't really, this heart rate, if the heart rate is less than 100, then it will move on to the else if statement. So in this case, because the heart rate is already more than 100, so it already meet the condition for the first one, then it will not move on to the next one. This is just like how your if-else work. And after that, it will look at the temperature. So the temperature is 30. Is it more than 38? Right now it's 39. So what it does is that, okay, it recognizes that this condition is met. Then I need to print out the alert. So this is how the whole interpreter works from top to bottom, line to line. Okay, so this is a modular code. So this is when you break your functions into individual parts. And how you try, and how, well, I just want to show like how does it run inside a modular code fashion. So after I will explain why it starts here in the next slide, why, but not from the first function. So right now it starts from your main function, which is a full assessment function. And then after that, it will move on to the next line, just like what I mentioned just now, top to bottom. So the next line, this is the function check the heart rate. So what it do is that it will move up and find where's the function, and then it will see if it meet any of the requirement, the condition, and then return the information that it wants to return, whether it's tachycardia or bradycardia. So this is the function. So every time when the interpreter notice that, okay, there is a function, then it will go, you can put it anywhere. You can put it above this code or below this code. Python interpreter will be able to find where is the function. So, okay, now you have the function check temperature, and then it will go back and try to find where is this function. If you don't have this function, it will show error message as well. So right now, manage to find check temperature functions, and then it will just run it and return fever because the temperature is 39. And then, so right now, both of this is done. Then it will move on to the last one to print out the diagnosis. Okay, so this is the part that you will see in every Python file. So when you're doing vibe coding, forming Python file, you'll all see this at the very end of your code. So this is essentially the place where it tells the AI where you should start. What's the first function that you should look for? Okay, so this is just like what I mentioned inside the command, this is what Python looks for when you hit run. So the Python interpreter will go through the whole folder, and this is the first thing it looks at. It will skip through all the functions and find this line of code, if name equal to main. And after that, it will start with this line of code and read, okay, it will start to print this first, and then print out the patient heart rate, the temperature. And as you can see here, the next function is full assessment. And this is exactly why, from our previous slide, your code actually starts from full assessment. Because when Python interpreter starts at if name equal to main, it looks through this whole line of codes and so that, okay, the first one, the function that it needs to go into is full assessment. So that's why it knows that I should start here. Then it will directly start with the full assessment functions. This is where it starts. Yep, and then now we'll move on to the full assessment functions, which we already gone through just now. And print out assessment is complete after the full assessment function run. I saw there are a couple of questions inside the Zoom on first of all, it's like the software and programs that we need to install in our laptops and also the requirements. So for the vibe coding, what we will mainly use is a software called Cursor. And then for students, we have student deals for one year, is it? Yeah, Cursor Pro. Yeah, Cursor Pro for free. So that's why we pick Cursor. And this is also the platform that you can use all those Cloud Force on it, those newest model for your vibe coding. And then also for the requirements of the laptop, I would say that because you will need to record a video of the presentation for the competition, so your computer will definitely need to be able to screen record and also audios and for that project, for the submission. So that's why it will be important to make sure that your computer can do that as well. And also there's a question on the necessary to download Python. Can we run tests on Collabs as well? So yeah, so you need to download Python for Cursor, or else when you run Cursor with Python, it will jump out a lot of error because the Python that you download right now is the interpreter of the Python. So you need to download it so that your laptop actually have the interpreter that understands your Python code and can make it run. And another thing about Google Colab is, okay, I will just have a brief talk about what is Google Colab for those that have never heard of it before. So Google Colab is another kind of platform for coding where you can actually code it, you can have code in different blocks and you can run individual block by itself. So it's not really like what we've seen most of the time in VS Code and also in VS Code or Cursor where you have a huge terminal and a huge IDE for you to type every code in, and then you have a terminal that runs the whole file. But with Google Colab, you can actually run individual codes line by line by themselves without running the whole program. So that is Google Colab. So of course you can test your code on Google Colab, but there are a lot of restrictions on Google Colab. For example, if you want to run an actual deployment and actual full stack front end, back end, it is harder for you to do it on Google Colab. It will still be easier to do it in a proper IDE, maybe your Cursor. So you can definitely test your code, and that is how I did most of the time, where I will test individual codes or individual functions that I never used before in Google Colab because it is faster and you can use the Google CPU and stuff like that. So you can use Google Colab, but for the main software, it will still be great that you use the IDE, the Cursor. Okay, so feel free to just pop any questions inside the chat whenever you want to, and then I will answer it after the presentation. Okay, so now I'm going to move on to deployment a bit. So it's local vs cloud. So where does your software run? So this is when you build an app, you need to decide where the brain lives. So local is you take a glucometer and then you just measure the glucose level of the person, but that just stays inside that glucometer. It will not be stored inside maybe the medical records. It won't be saved inside the huge system. It will just be stored inside that particular machine. So that one is local. So local is private because only those that use your laptop can actually see it because it just runs inside your laptop. It uses everything inside your laptop. It uses your laptop CPU, your laptop computational power, and everything like that. So it can be offline because it's not connected to the internet, and it is faster, but the problem is that it has limited power because it depends on how good your laptop is. And other people have no access to it. Another one is in the cloud. So the cloud is just a fancy term on like renting someone else's supercomputer. So like AWS from like Amazon, you have like Microsoft, you have like Google, they all provide a lot of like very strong server that you can run. So that is where if you try to deploy your software to like other people to use it so that everyone that have internet access can use it, you need to put it inside a cloud. So you can search it out. You can use AWS, you can use Amazon, you can use all those like different cloud server to help you run it. Another problem with local is that when you close your computer, your laptop, or when you stop the code that is running inside your laptop, then everything will just stop. No one have access, everything just gone. But for cloud, this server, because it is run by and managed by all those big companies, it will be on all the time, and then they will do all the maintenance for you. So this is a good thing about the cloud. So this is also something really important when you are thinking about making projects that is related to healthcare, because privacy is a huge concern. And we do have projects that the doctor or the hospital will ask us to make sure that the software run locally in their own hospital server, because they don't want it to run inside the cloud where everyone have access to it, because we are dealing with like patient data, all those confidential data. So this is something that you need to think about it, and every hospital have different regulations and stuff like that, and this is definitely something you need to be really, really careful especially when you're dealing with all those sensitive data for whatever project you are working on. So this is also the difference between prototyping and actual deployment. When you're trying to just prototype a product, you're not using any real information or anything like that. You can just run it on your computer, do whatever you want. But when it comes to deployment, especially for healthcare, when you have all those sensitive data, you need to think of a lot of other stuff like, can I actually run it in the cloud? Because it means that other people might have access to it. What about, and also if you run it in the cloud, the server is actually offshore. It's in like US or some other countries. That means that this sensitive data is being sent outside of like Australia or outside of your country. They will have some privacy concern there because of that. So for example, for clarity, I can just run it locally and then just play with it by myself, or I can deploy it using all those different servers out there, AWS. It depends on what the hospital like. Okay, so now I'm going to talk about database. So just now we talked about variables, which is on storing information, and database is something similar. So it also stores information, but the thing is that when you're doing variables, there's one limitation, one huge limitation. When you stop the program, everything is gone. So it's just temporary. So it's like the RAM of your computer. It is a temporary memory. You stop the program, everything's gone. You will never be able to find it back. So that's why you need to have database. So database will store the information permanently. So you have a lot of different types of database. One is files. It's like CSV, like JSON files. It is good for quick notes, for smaller tasks, but it gets really messy if you have like few thousands or more than that of data that you want to put it in. It will be really, really hard to, especially if you try to track down like maybe a specific points, it will be really difficult to find it. So that's why we have a lot of other database like SQL database. So SQL, you can think it as Excel sheet, but for coding. So the store all your information is in a really rigid and fixed way. So this column is just for names, for strings. This column just for integers, for maybe the patient ID. And the next column is just for address, and it is fixed. You need to follow it step by step. You can't really put in other format or any other information in. So that's why we have no SQL, where it is way more flexible and you can just throw anything you like. You can put in like the notes, the discharge summary, the X-ray pictures, anything that you like into this database. They don't have the restrictions like SQL. Okay, so for clarity, we use a slightly new type of database. It's called vector database, which is kind of like exploded in popularity only in the last few years because of AI. And for the clarity project, because we want the AI to be able to get the information, and also we don't want it to be like a keyword-based search. So for example, if you search for like stomach pain, for keyword search like SQL, no SQL, they will directly find words that matches exactly stomach pain only. But for vector database, they will find not only stomach pain, they will look for intestine, they will look for like abdominal, like all those words that are semantically close to like stomach pain. So that's the good thing about vector database, as this is something that we'll also talk about it in the next few days for like other lectures, more about like how vectors work. But essentially, they make all the words into numbers, into a coordinate. And then they find, using that coordinates, they see which one is closer, has a closer meaning to that particular word. So in the clarity, we use it to find medical knowledge that is relevant to the user questions. Because for same parts of pain, we have a lot of different types of pains. We have a lot of different words to describe the same thing in medicine. And especially that sometimes people have different like short forms, have acronyms and stuff like that. So you need to understand what's the meaning of the words and find words that have similar meaning to it, just in case you miss all those words that is actually referring to the same thing, but we use different words to express it. Like angina, heart attack, chest pain, they're all similar. So if you use a vector database, they will get information that is related to all those things. Okay, so this is actually like a conclusion. So because I'm trying to kind of like put everything together on like what we gone through just now on like the coding language, and also like the software, and also how we change things into like actual software, how to run it like interpreter, and how we connect it to external better like code that already been done by other people. How can we use it, or how can we use other people's server that is stronger? So if you look at this picture, we have front end. So you can think as a user. What the user see at first is the front end. And I will use clarity, for example. So the front end will be like what I showed you guys just now, the videos and the image of like the front end and how it works. And the user put in a query. When they put in a query in, what happens is that when the user press enter, you have all the flags, you have like the JavaScript that I mentioned, they will actually recognize that, okay, the user press enter. What should I do? I should post a request to the backend. So now it will send an information to your backend. And backend is where all the magics come from. Inside your backend, you will have the application logic, which is using Python that we will keep on talking about. So this is where the software look at the input and think about, okay, what should I do now? Okay, so now having this input, the first thing I should do is let me embed it into vector that I just mentioned just now, coordinates, and then I should send it to the database. I send it to the database and see any document or information that have similar meaning to what the patient asked, the user asked. So it will move on to the database and retrieve the information that is important. And then after that, after it retrieves the information that is needed, it will send the input and then the information that you get or the guidelines you get from your database, send it to the AI through API keys. So API keys is where you give all this information to maybe if you're using ChatGPT, or you can use Gemini, any of these models that is running in the cloud in like maybe ChatGPT's headquarters, like their own server. You send it there, and then the API keys send it to them. They will give you an output, a response based on your query, based on the guidelines you give them. They will give back that to your backend, and your backend, after receiving that information, will, okay, now I received this information, and then it will continue to follow your application logic. What to do after I receive the information from the LLM, from ChatGPT, from Gemini. Okay, after I get it, I should return it, or maybe I can format it to make it even better, more organized. You can do all sorts of things with the output. and after, or maybe you want to make sure that there's no sensitive information or anything like that. After you're done with all those processing, your application logic will tell, okay, now backend will send the information back to the front end, and the front end will display it out, display the information that you send back to the front end out to the user. And that is where the user will actually see what is being done and what's the output that it gets from that query. So this is a really simplistic way of trying to like have a general overview on how a software runs, and also what happens when you actually interact with the front end. When you press enter, what's happening underneath the hood. And also important to note that for different software, they will have slightly different backend logic for sure, because they all have a different functions, right? You can have like a software that actually talks to the patient. So the AI will talk to the patient or take history from the patient. In that case, the front end will be the user say, okay, today I presented with, I have abdominal pain. And then we go to the back end. And then after that, it will move on to API keys, right? It will send this query, the input from the user, send it to like a Gemini model, a ChatGPT model, and then the model will give an output. Okay, how long have this been? It will go back to the back end. The application logic notice that, okay, you have this input right now. You have this information from the LLM. Now, I want to send it back to the front end and talk to the patient. In that case, you will also have a database, because you need a database to store the chat history. Because you need to have that chat history to make sure that this LLM actually have a clue on what is happening right now. Because every time you send a message in and out and get a response from the LLM, it actually forget everything. So that's why you actually need to append or join every line of like the text, the conversation. So every time, okay, the first time you talk about like presented with pain, and then after that, the AI asks about, okay, when's the pain started? And then after that, the user said 3 days ago. So all this information you need to add on the chat history and send everything to the LLM. So the LLM have a context on what is happening. So that's why you still have a database to store the chat history, and then make sure that the LLM have a better overview, have at least know what is happening, because you need to go through the chat history to make sure that, okay, did I miss anything? Did I miss any information that I need to ask? And then it will just ask any of the question and make sure it didn't miss anything. So these three things are like a fundamental building blocks for most software. So most of the software, you will all have these three components. It's just that the way you use it, the way you join them might be a bit different, depends on what the software you want. And you will use all this and also try on it during the vibe coding workshops next week, and you have a better idea on what all this means. Okay, so that's it for today, and hopefully by now, when looking at software and looking at codes, it won't be as daunting as possible, and you won't feel like as complicated as before, because now you have a better idea on how software actually works, and also what happened underneath the hood. And during the vibe coding session, you will start to do all the coding by yourself, and at that point, you'll be able to utilize all these concepts that you learn or listen today and apply on the vibe coding during the vibe coding workshops, and build whatever you want. And yeah, feel free to ask any questions, and thank you very much.